All right, and for this last video in section 15.7, look at problem number 7. It says, let S be the paraboloid z is equal to a times the quantity 1 minus x squared minus y squared above the xy plane, where a is a positive constant. Assume that S is oriented upward, and if our vector field f is x minus y, comma y plus z, comma z minus x, the question says, what value or values of a, if any, give the maximum value of the surface integral of the curl of our vector field over this paraboloid. Okay, so here are a few paraboloids by choosing different values of a here. And our job is to figure out the value of a, if such a value exists, that will maximize the surface integral of the curl. In other words, we're going to maximize the total circulation throughout the paraboloid. All right, well, the idea here is to first identify the boundary of the paraboloid. And the key insight is that the boundary is in fact the same for all choices of A. And the boundary in fact is just the unit circle, because if I set z equal to 0 in the paraboloid equation, then dividing by A, I get that x squared plus y squared is equal to 1. And so I have a common boundary here, so I'm going to use Stokes theorem to compute this surface integral as just the line integral of our vector field f around this boundary circle in the xy plane, just the unit circle. All right, so here's a parameterization of the unit circle, cos t sine t 0. T varies from 0 to 2 pi, and here's our derivative vector. So let's go ahead and compute that line integral. And so f of r of t, what's that going to be? Well, we're setting x to cosine, y to sine, and z to 0. And so for the I component of f of r of t, we're going to get x minus y, so cosine t minus sine t. For the j component, y plus z, and so that's sine t plus 0, so that's just sine. And then for the k component, z minus x, that's 0 minus cos, so that's negative cosine t. We're dotting that with the tangent vector here in blue, and this dot product comes out to be sine squared of t. And using this identity here that sine squared is 1/2 times quantity 1 minus cos 2t, we find that the value of this line integral is equal to pi. And notice this answer is totally independent of the value of a. But that makes sense given the fact that all of these paraboloids share this common boundary circle, C. Okay, so C, of course, not really knowing or caring what the value of A is, right? It makes sense that it's just going to kick out a value that's independent of A. And this also speaks to the fact that Stokes' theorem, right? Remember, it says the total circulation of your vector field over this surface is equal to the circulation just on the boundary. And so, since all these paraboloids share that common boundary, it would make sense that our answer here is just a number independent of A. And so the conclusion is that this surface integral is equal to pi for all positive values of A. And so again, the question is what value or values of A will give a maximum value of the surface? Well, this surface integral is constant with regards to our choice of A. And so that is the maximum. Okay, cool. Well, that's going to do it. I will see you in the next series of videos on the divergence theorem. All right, bye.